Hello and welcome back to the lab. Welcome back to EE for everyone. Today, I want to walk you through my experience setting up and using the QHE SMT TMV802. You might see this from a lot of different brands called the TMV802 or TMV802A or B or BX or AX. They're all variants of the same thing. I believe they all use very similar software. And the reason why I'm making this video is because I couldn't find a comprehensive guide of how to set up, calibrate, and use this thing. So I just want to walk you through most of the menus and some of the pitfalls I ran into. Hopefully this will complement some of the other videos that are already available pretty well. So I just kind of want to answer the questions that I couldn't find right away and the things that are probably in the manual, but never bothered to read it in that level of detail. So, let's go through this together and really talk about it. But before we boot up the machine, what we need to do is we need to go over to the computer and we need to prepare our data. This is actually a project that got scrapped because there was a time when we were messing around with DMX a while ago, and if we wanted to do more with that, this was kind of a gateway to get a controller on the DMX bus that could do all sorts of crazy things. But we never really did that, so I never really needed this board, and now that's why this is the first time you're seeing it. There's only one problem. I never intended to build this board with a pick-and-place machine, and I never even bothered to put fiducials on it. So that means we're going to have an interesting challenge today where it's what are we going to key off of to provide a reference for where this board is located in space. We're going to talk about that in a minute. Before that, I want to walk you through a template that I made. Basically, I paste the BOM with a link to a proto identifier. I then have a position file. This is exported from KiCad. There's a lookup table that maps some of the key parameters, like which feeder that is installed in, what nozzle number I want to use, the height of the component. Obviously, there's some improvements that could be made. I should probably actually put some heights in there. This is pretty rough. And then the output cal, this is a list of the different references for calibrating in the board. You can see I have mounting hole 1, 2, 3, and 4 listed with their coordinates. We'll need that for programming the machine in a minute. We then have the output position file, which merges the reference designator with the nozzle number, stack number, physical location, rotation, and some other things that this machine needs, including whether or not we're using vision, what kind of check we want after it's been placed, brief summary. I've copied this and put it into this CSV file, which we're about to import in the machine. Let's go do it. All right, we're booted up in the machine and go to open the file and launch Surface Mount. I have this machine disconnected from the internet. All right, connection failed. First of many errors, I'm sure. Before we get into that, I just want to walk you through what was provided with the machine. They provided these screenshots of different system parameters. I believe that I went through and I tried using all of these, and when I did that, they were a little off. Most of them were pretty close, but they just weren't quite right. And we're going to talk about some of these that we need to tweak in a moment, but they provided this baseline cal in case I forgot. So this is saying connection failed, and that means it is time to turn on the machine to undo the e-stop. And that is really unfortunate because this thing squeals at a high pitch and it really annoys me. And it's on. Hopefully you can't hear it. I will filter it out so you don't have to suffer. We have turned on the machine, click OK, and it has now launched the program. First thing you're going to need to do is home the machine. With the machine homed, we can start to think about importing our data, but first we need to install our board. Given that this has a component that is hanging off on one side, I'm going to install it like this so that the component hanging off on the right will not have an interference. And you slide these clips up so there's just a little bit of pressure. You got to be mindful. I'm not going to use this third clamp simply because this board will be really, really easy to install crooked. In fact, I'm just going to place another board over on the right. As you can imagine, if you're pinching this board and you don't have nice parallel edges, you're going to have some problems. That'll allow us to use the third clamp. So we can now clamp it down a little more, and then to remove your board, you just pull back on the clamp, pull your board out. Makes it pretty easy for material handling. They provide a little stop so you can consistently place the board. Okay, you can see that we have this with one manual tray feeder on the manual parts tray. We have a bunch of tape installed over on the right with one of these. Looks like it broke. Oops. We'll talk a little bit about tensioning in a moment. And yeah, all right, let's load up our file and let's get this thing going. The first thing I want to do is load a file. We selected that CSV file, and now we're telling it what we have here. We have the top, and we have all the components. We click OK. And it helpfully blew away our vision, which is great. Everything imported terribly. It didn't even grab stack number. All right, well, looks like what we need to do is we need to save this back to our flash drive. We can just edit those parameters, and I'll show you why I'm importing it and then overwriting it in just a second. Back on our computer, we have opened up that output file, and you can see it's completely blown away some of our options here. That's pretty annoying. Oh, it's probably because we had invalid data for some of them. Well, we can resolve that pretty quickly. I'll just tell it to grab from L2, all those. That'll be our signal that we don't want to populate it. So the reason why I exported this is because it's faster for me to just update the values here. And this pick and place machine has a bunch of random unlabeled cells that need to be exactly right that store a lot of the different settings for each of the parts. So you need to import it so it'll add all that extra data. Then you can come through and just edit the couple fields that need to be edited. And it looks like that's really all I needed to do. We have the designator, we got the stack number, got the nozzle number. Just going to update the big part to use the big nozzle, and great. And yeah, go ahead and save that, and we'll switch back to the machine. With the flash drive plugged back in, we're just going to grab that out file, and you can see now our stack number as well as the vision setting is being recorded. And now we need to go into a little bit of PCB config. All right, we need to give it a Mark 1 and a Mark 2. This is how we will tell it where the fiducials are. We're going to find our fiducial. All right, I'll switch to low speed. Now, this is a perfect example of why fiducials are incredibly important. Doing this without a fiducial, that's not great contrast. This might not work. We might need to pick a pad to reference, but we'll give it a try, and we'll see if it fails. So we'll call this Mark 1, and we know the real X and Y coordinates. This is X in the left-hand column, Y in the right-hand column. All right, and Mark 2, we want to do something on the opposite corner, so that would be 101. So those coordinates will be 145 and 99. That's not right. 145 and 129. All right, now we just need to find it. And we'll do a set XY. Now we can quick double check that we do indeed have our fiducials in place. Click OK, prompts us to save. We'll do just that. All right, so our PCB config is correct. So we are on Mark II. Going to get it. Ooh, need to make that size a little bigger. Let's try 5 millimeters. Get. Looks like we got it. PCB thickness is 1.6 for this board. Looks great. All right, we're going to go to Mark I. Go to config. Get that. Excellent. All right, looks like we got it. We're now able to test. We actually identified it. You can see from the color change. This might actually work. We're getting really close to placing our first component, but first let's just confirm that our calibration actually worked. So we'll click aimed with camera, component overflow. Oh boy. It was a simple mistake. So I was manually typing a coordinate system and I missed the sign on these Y values. Okay, that's going to make a big difference. Let's try that again. Let's try aimed with camera. Okay, that was supposed to be C104, and it looks as though we've got C104. Let's grab another part here. Aimed with camera. Should be R106. Whoa. Hello? Looks good. Looks good. Looks good. Aimed with camera. All right. So it looks like we're actually lined up pretty well. Note, this is based on our manual entering of the fiducials, so it's only going to be as good as our fiducial recognition. What I've needed to do for each of these components, if we grab component 5, and we tell it to move division to that value. It should be looking at the place where it's going to pick up that component. Great. Now we can say stick in the advancement, say advance it by 1 position. Now we're going to tell it to move the nozzle to it, and if everything is calibrated correctly, and it looks like it is, we've got a resistor underneath that nozzle. So we had to go through and calibrate that for all of the stacks. I guess I can just go through and show you. So now that we're there, it's pretty well calibrated. It's not perfect. What we'd want to do is put it exactly in the center of that component grab spot. Oh, we'll just nudge it a little to the right. And what we need to do is click Set XY with that new position. And that's really all we have to do. The feed is how many millimeters that needs to move to advance to the next component. You want to make sure that's set correctly. So 0402s, I believe, will be 2, like 0603, 0805. A lot of those will be 4 millimeter. You can check the tape. I think this 8 millimeter is a SOT23. So yeah, you just need to set that correctly. And the prick offset is the offset from the camera to the needle that comes down. So if you notice, you're getting it centered in the camera, but then the needle comes down and it doesn't grab the tape correctly, you'll need to adjust this prick offset so that needle gets down into the hole to advance the tape. So that's kind of what's on this screen. These are not super necessary because we added the component height on our side, but you could add like a component library in here and add your component parameters here as well. So IC stack is what's next, and this is something that I had set up for a different set of components, and I might need to run that again. So I might just come down to one that hasn't been configured, like here stack 11. I'm gonna hit a go to, and you can see stack 11 jumped nowhere close to where we want it to be. So we'll tell it to advance to the right, and we'll center stack 11 as close as we can. Now this is a little bit of a trick. Trying to center that when the component is huge. What I'd recommend is if you have components to spare, in this case I kind of want to use this, but if you have components to spare, you could cross an X on that top can, and then you can center that here. But instead of doing that, I'll just grab this component, looks close enough. We have one column, we have one row, we have one IC. So when we tell it to go to stack 11, it should be good. So we're going to tell it to move to stack 11 with the nozzle. Hello? There we go. Nozzle move 2. Nope, that ain't it. We missed. All right, high speed. There we go. Now this might be a little easier to find the center of. All right, we'll reference off that USB port. Should be roughly centered. And we'll come down to grab the actual can. There we go. Now we'll save that. Excellent. Nozzle move 2. And it looks like it moved to nozzle 1, which is totally fine. And yeah, that's actually pretty close to the center of the component body. So we'll call that good enough for our example here. So now to use that, all we have to do is where we used to have I1, we want to pick I11, and now we have that offset programmed in. All right, coming back to the config. We have a bunch of other configurations. We're saying when we come down to the stack, what's the offset? When we come down to discard, what's the offset? When you come down to the front, what's the offset? What's the offset down to the PCB? Then these are the offsets from the nozzle to the camera. This is the mobile camera that we're measuring the offset to. That's an important offset because if that's wrong, everything that we've just dialed in is going to be incorrect. So it's important to calibrate that. These delays are for when picking and placing with nozzle 1 and nozzle 2. So it's, after you place, how long do you want to dwell there so you can make sure the vacuum actually dissipates and you're actually placing the part. Switch over to the camera. Very, very similar. Nozzle 1 camera position. That is where the machine moves to when nozzle 1 is perfectly centered in the camera. I'll hit move. All right, there we go. So now if I switch cameras, what we should see is the nozzle. And you can see there is a nozzle in the center of the camera. Now, there's a problem here because if we actually rotate the nozzle, what you'll see is that wiggles just a little bit. And likewise, if we move the nozzle 2, you can see this one will rotate as well. It actually moves. Maybe I'll do that low speed. And you can see that nozzle isn't perfectly centered. That's just going to happen. There's going to be some offsets, and those errors can come from lots of different parts of the chain. It can come from the nozzle itself being bent, that vertical column that the motor is spinning being bent. There are so many places that can come from. So this is going to be important to dial in as well. There's some thresholds here for vision that I don't fully understand. But yeah, if you guys have a ton of experience with this or you found a good article, by all means, link to it. There was a general description in the manual, and it wasn't especially helpful. This angle offset, I believe, is meant to compensate for that rotational error, but I've never adjusted that value in a way that made my placement more accurate, which is kind of unfortunate. So yeah. Ooh, maybe that's what I'm looking for. All right. Anyways, here's all the other offsets that you need. Where the discard is, all this and that. So anyways, let's actually get in here and let's do some stuff. I have not used this quick debug yet. But maybe if you guys are interested, I can figure out how the heck this works and walk you through that. For now, I'm going to put some double-sided tape on that machine, and we are going to place some parts. So we're going to come in to auto. No, what do we do? We're going to run and hit run. It's going to come and try to check our fiducials. And then I need to hit step. It's checking our second fiducial. Looks good. It's going step by step. Came over to check. It's doing the visual correction. Now it's getting ready to place. All right, looks good. Let's hit go. I made a pretty simple mistake. It is pretty evident that some of these parts are not in the right spot, and there are some pretty obviously incorrect parts placed. Well, turns out when I was pasting into my CSV, I was apparently rushing, and in that hurry, I pasted the formulas, not the values, into the CSV. Yeah, it didn't work so well. So we mixed up all of the feeders and the coordinates, and it put parts all over the place. So let's try this again. There are multiple vision settings. This is running accurate. So the reason why it's dwelling over the camera so long is because it's sitting there trying to figure out where exactly to place each part, and it's compensating for each little minute difference of angle and position, which it's not necessarily ideal. Most of the time, you'd probably want to use the fast configuration, simply because it's, well, faster. This is looking much, 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 much better. We're actually placing the parts in about the right spot. Oh man, that is great. I can't wait to show you guys this one under the microscope. That was about to be an embarrassing tutorial if it was that wrong. Yeah. Ugh. Oh, I deleted our... Oh, well, that's disappointing. I deleted our cool, fun module. The only thing I wanted to tell you about the module is, well, there's actually an issue when I made the footprint, so that's not very exciting. Under the microscope, first thing I want to do is just show you a scan top down, as close to top down as I can get, of where these components got placed. And there's a few things that I want to talk to you about. So as we look at where this all got placed, there's going to be two major types of errors. You're going to see global offsets. So, like for example, if the nozzle to camera offset is not correct, you're going to see an offset on every single component that gets placed, because of course it's like homing every single component based on where that camera is. So that offset needs to be dead on. And unfortunately, because our fiducials were so bad, we have two different kinds of error. You can see that pad on the far right is shifted a little bit up and a little to the right. And then as we go to the other side of the board, you can see these are actually shifted a little bit to the south and even more to the right. So that means not only is there an absolute error, there's also a relative error, because when this came into home and it tried to find the center of that fiducial, it was a little bit wrong on one or both of those exact centers. Now, of course, if you had a real fiducial and you had a high contrast pad, something more like that shiny cylindrical pad right there, if we would have keyed off of that, we would have had a much higher chance of success. I probably could have tried to use that one pad of D10 and that upper pad of that switch, and perhaps we would have had better success. I didn't. I was kind of making a point, but you just give it a coordinate and you take a picture. So you can use anything as that fiducial. You just want to try to make sure they're on opposite ends of the board. So what I'm trying to say here is fiducials matter, and high contrast fiducials matter quite a lot. And I'm showing you this. You can see all the ugly glare. That's because once I tip this up, we're going to see that parallax error from having this being slightly misaligned. It's going to look a lot worse than it really is. But that's because we're looking at it at an angle to get rid of the glare. So, yeah. And where it placed the module is just about right there. And you might say, well, how could it place it so far off? Well, I have a feeling I can tell you. If we come back in CAD and we click on this footprint, you can see the origin of this footprint is that bottom left corner. And what the pick and place machine is expecting is that the center of the footprint will be the centroid of that component. And so the offset that we're seeing in the placement is the offset from the center of the part to that bottom corner, that 0, 0 reference for that footprint. And that's why most footprints, like when you come here and look at the SOT23, the center of the centroid of the part is the center of the footprint. Same for all these passives. Center is center. Same for this IC. The center is the center. And you got to be mindful of that when you are building your footprints. It's like start to finish, every little detail matters. And that difference is, when I flip back, that's the difference right there. So at any rate, I really like this pick and place machine. And if you're just getting started, hopefully what I just walked you through, my crash course of here's all the settings on the pick and place machine, hopefully that'll help you start placing boards. While my configuration isn't perfect by any means, on all these parts, it's close enough that if you had solder paste down and you placed it and you reflowed it, it would work. So yeah, hopefully as I continue to use the machine more, it'll get even more accurate and even better. But what we just walked through was fundamentally what I needed to know to get started to actually get up and run and use my TMV802A machine. So if you found this helpful, please leave a like, comment down below if you have any additional questions or things you'd like me to learn. But for now, I think I'll say goodbye and thank you for watching. But most of all, I hope that you learned something great today, and I hope to see you again soon. So thanks for watching Eat You for Everyone, and we'll see you in the next one. Bye.